Okay, first problem that might appear on your test is order of operations. I just want to caution you, I'll just do a quick example. But I don't want to see just an answer. I want to see the steps because you can plug it into your calculator and get the answer. And that's, of course, one way to check your answer. Another way to check your answer, of course, is document I handed out to you and you got the answer. Okay. And do let me know if you find that there's an answer there that doesn't seem to be right. Because this is kind of a beta version. I would not be surprised if there's still a couple of errors. Okay, so let's just say we got 2 times 3 raised to the second power plus 4 divided by
Have a good day.
5 plus 2. Okay, let's just take that much. How do you do this? Well, the first thing you do is exponentiate. So you're not going to multiply the 2 by the 3 because the exponent takes precedence. So you're going to get 2 times 9 plus 4 over 5 plus 2. Now, what's the next thing you do? Well, the next thing you do is multiplications and divisions. You don't add the 5 and the 2. You don't add the 9 and the 4 because there's a multiplication involved with that 9. You can't add it to anything. Okay? At least until you've done the multiplication. And there's a division related to the 5. You can't add the 5 to the 2 until you've done that division. Now that should be very familiar to you. We got good old PEMDAS, which I think is. Now we could write that down. The 4 divided by 5 means 4 over 5. We could write that as 4/5 plus 2. And then we can add these. Okay. Now, to add these, we would have to express 18 as 90 over 5, 4/5, and 10/5. Using a common denominator, and I'm not going to explain that. You review fractions, you need to do that. And that gives you 90 plus 4 plus 10 over 5. And if we add that up, we get 104 over 5. Ideally, I would see all these steps, but one thing I don't want to see is just an answer. Because you will have access to just a very basic calculator, the one you can get to use in the testing step. And you could punch this stuff into the calculator and it might even give you the right answer. Okay. Of course, you're welcome if you don't get the right answer to punch it in your calculator. If your answer disagrees with what you have here, well, I'll tell you, I wouldn't trust the calculator. I don't know how well that calculator follows the order of operations. I know, for example, that Excel spreadsheet does not follow order of operations in many cases. Okay. It was written by accountants, not mathematicians. Although mathematicians and scientists make great use of Excel, it's a great thing. You got to be careful about it. So I wouldn't rely on the calculator. I would show all the steps. Even if you make a mistake, you might get partial credit if you got the steps. All right. We don't want to take too much time on this. The next topic that's covered here, and there are several problems involving linear equations. Okay, so I'm going to just do 2 examples. Let's say we've got 5 times 3x minus 4 plus 6x minus 2 equals 4 times 5x plus 7 multiplied by or added to 2x minus 5. Okay, that's a mess, but what do? Well, we use a distributive law. We multiply 5 by the 3x minus 4. We get 5 times 3x, which is 15x, and minus 5 times 4 is minus 20. Then we have plus 6x minus 2. Over here, we multiply 3 by 4, we get 20x plus 28 plus 2x minus 5. Now, 15x and 6x makes 21x. Negative 20, negative 2 gives us negative 22. But we can't add the 6 and the negative 2. We can't add the negative 20 to the 15. We can't add the negative 20 to the 6. That's just plain old order of operations. But also, you can think of that as 15x and 6x are like terms. They have the same power as a variable, okay? So they can be added. Negative 20 and negative 2 are just numbers. Just plain numbers are automatically like terms. They can be added or subtracted. Okay? 20x and 2x is 22x. 28 negative 5 is 23. And large number, I think I can screw up. Okay? Then what I want to do is subtract 22 from both sides. I'll just kind of put a circle around that. I write it in linear form. People are tossed right at 22, negative 22 here, and a negative 22 here, and by black magic, they get the right answer. If you write negative 22 equals negative 22, then officially you can add those equations, left side and right side. I'm not going to penalize black magic. If you get it right, it's okay. All right. 21x minus 22x is negative x minus 22. Seeing the 22x and the minus 22 makes you kind of want to do something with that, doesn't it? Probably does. Okay. You see that, and you know, you could do, well, there's things you could do with it, but they're not going to be helpful solving the equation. These are unlike terms. You're not going to combine them. You can factor 22 out of that, but that would be completely unhelpful. And 22x. Whoa. Whoa. I should be subtracting 23 instead of 22. Okay, too many numbers in the low 20s. My eye picked up the 22. And when I get over here, since I'm thinking step by step, I don't just cancel a couple of things that I think ought to cancel. I check and I see, wait, 22x and minus 22, that doesn't do anything. And 23 minus 22 doesn't get rid of that 23, and I don't even want to do that. What I want to do is subtract 22x to both sides. Right. When I wrote the 22 down there, I didn't put the x on it. And then everything fell apart. And that's going to happen to you in the test. See, I was pretending to make a mistake. I didn't make mistakes. Okay, well, yeah, thanks. You get 21x minus 22 minus 22x. I choose to do the minus 22x because I don't want 22x on this side. I want all my x's on this side. So this is progress. I've got 22x plus 23 minus 22x. And now 21x minus 22x is negative x minus 22. And 22x minus 22x is 0. So we're just left with 23 on this side. And then we have minus x minus 22 plus 22 equals 23 plus 22. So again, up here, I subtract 22x from both sides. Here I'm adding 22 to both sides. And when I add 22 to negative 22, I get 0, so that leaves me with negative x. And here I get 45. Then I'm going to say multiply negative 1 by negative x is negative 1 by 45. That gives me x equals negative 45. And then, I don't want to see you do that. I want to check. So come back up here and check. Our check is going to yield equation 5 times 3 times negative 45 minus 4 plus 6 times negative 45 minus 2 equals 4 times 5 multiplied by negative 45 plus 7 plus 2 times negative 45 minus 5. Now, if I've done everything right here and I've written everything right out here, I just need to find the numbers here and find the numbers here. Didn't close my parentheses here. Gotta be careful about that. Okay. 3 times negative 45 is negative 135. Minus 4 is negative 139. So I'm pretty sure of that, so I'm going to write that down. 6 times negative 45 is negative 270. And then 5 times negative 45 is negative 225. Add 7, we have negative 218. 4 times that is 872. And then we have minus 90. Negative 270. Sorry, minus 5. So applying this out, we get 615.45, which is 695. And it's negative. Minus 270, minus 2. And then these numbers we can just add up. We get negative 872, negative 90 is negative 962. So we get negative 967. Now, I'm optimistic because 2 and 5 gives me 7. And that gives me negative 960. And this gives me negative 967. And this is negative 967. So there we've checked it. And now we're sure of the solution. And I really do want to see you do that on the exam. Because if you've done the steps essentially right, and just have one bonehead error like you saw me make, and check it, and show that your solution isn't right, but you just can't figure out what you did wrong, you might still get 6 points out of 10 in the problem. If all your steps were right, maybe even 7 points out of 10, because you checked it, okay? You're going to get more points if you checked it and found that it was wrong than you would if you just worked it and it was wrong, okay? Okay. What other? Distance on linear functions. Let's say we've got 5 over x minus 2/3 equals 7 over x. X is in the denominator. You can't solve this equation with x in the denominator, at least not by the methods that we're using. On the denominator, I'm gonna change this just a little bit. I'm gonna make this 5 over 4x. I'm gonna make this 7 over what the heck, 5x. Okay, what's our common denominator? Well, we're not going to take time today to do that because we've got a lot of problems to demonstrate and so forth. Okay, I want to give you pretty good foundation for working these problems and able to work them. So I'm trying to move kind of fast here. your common denominator is going to be 60x. Okay, it's got to have an x because there's an x in every term. It's got to be a multiple 4 and a multiple 3 and a multiple 5. And 4, 3, and 5 don't have any common divisors. So you're just going to multiply 4 by 3 by 5. Now you have problems that have been assigned, presumably done, where you work on finding common denominators. So you have to know how to do that. Okay. So we multiply by common denominator. Now, since we're multiplying by fractions, most people are going to find it helpful. Write 60x, 60x over 1. And that's then multiplied by 5 over 4x. And then it's minus 60x over 1 multiplied by 2/3. And that equals 60x over 1 multiplied by 7 over 5x. When we multiply fractions, we multiply the numerators and we multiply the denominators. It doesn't work like that when we add fractions. When we add fractions, we have to use common denominators the way I did with the order of operations problem. Couldn't just add the numerators and add the denominators. That doesn't work. But when you multiply, it does. Okay. Well, 4x will divide into 60x. 15x times. So I don't like cancellation, but I'm going to do it because that's what the math tells me to do. I've told you why I don't like it. If you picked it up, great. But a factor of the denominator is going to include 4x as a factor. That means it's going to be one of the things you multiply to get the denominator. Of course, the other thing is 1, so that's just going to be your denominator. And 4x is a factor of 60x. It can be divided into 60x. That doesn't give you 15x, it gives you 15 because the x divides the x as well. Okay, so you get 15. Over here, 3 will divide your 60, giving you 20. It doesn't divide the x. So you get 20x times 2, which is 40x. Over here, 5x divides into 60x 12 times. 5 into 60 is 12, x divided into x gives you 1. And you just end up with 12 times 7, which is 84. And now you have an easy problem that I'm not going to take time today to solve. You've now reduced this to a very simple linear equation, much simpler than the one we just did. So you just solve it and check it. And of course, when you check it, you got to plug your solution, which will be what, negative 89 over 40? No, positive 89 over, no, yeah, negative 89, no, negative 69 over 40. Okay. You plug negative 69 over 40 in for x and do the arithmetic of the fractions. Check. Now, people are not real comfortable with fractions. So, something you probably want to hone up on just a little bit. Okay. Now you notice on the set of problems I gave you, there are 5 problems labeled linear equations. Okay. And then there are 3 problems labeled equation with denominator. Okay. The second one of those equations comes out to be a quadratic, but we haven't talked about how to solve quadratic equations, so that problem won't be in your test. Okay. So I did include it in your sample tests. Because I want you to kind of be aware of it. I want you to be aware that if I have an X in the denominator, but an X in a numerator, when I multiply by my common denominator, I'm going to get an X squared. And if I've got an X squared, it's no longer a linear equation. Now that's kind of important to understand now, so you don't stumble over it later, but it's not going to be relevant to the test because it won't appear. Okay? And if it accidentally does appear, well, if you tell me, oh, gee, man, that's not a linear equation, I'll give you full credit. If you even multiply by the common denominator, get the right thing, I'll give you full credit because there's no way I can expect you to know what to do after that. You will in a couple of weeks. And it's not difficult. You just have to identify that you have what we call a quadratic equation. Okay. Now we have absolute value equations. Just have to squeeze one into this space here. Again, I can't develop all the logic of this, although we did it in class. So might go back to some of the videos or go back to the open math videos on absolute value. It'll tell you exactly the same thing I'm telling you, but in different words. Okay, so if we have an equation like 4 times the absolute value of 3x plus 8 equals 12. Okay, what do we do? Well, the first thing we do is we get rid of anything that's not the absolute value on this side. So we divide both sides by 4. So now we have absolute value of 3x plus 8 equals 3. Now, the logic of this is very simple, but there's an epidemic of students thinking that all you have to do now is take the absolute value signs away and solve it. No, 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 please. Okay? The absolute value of something equals 3 if that something is 3 or if it's negative 3. So you break this into two equations. 3x plus 8 equals 3. 3x plus 8 equals negative 3. Okay? Then you solve this equation and you solve this equation. That's all there is to it. But you need to understand what absolute value means. Okay? The absolute value of whatever's in here is 3 if whatever's in here is 3 or whatever's in here is negative 3. And it doesn't matter what's in here. That's always going to be the case. Now you can't do that up here because you got the 4 in front of it. Okay? Divide both sides by 4 until you get absolute value equals. Okay, so we solve this. I'm just going to say et cetera, et cetera. We subtract 8 from both sides. Then we're going to get x equals negative 5 roots. Incidentally, I like to put the word or. Okay. This quantity could be 3 or it could be negative. The logic is important. The logic keeps getting suppressed in our math education. Now, you can overwhelm people with the logic, but the idea that it's this or this, people don't understand that logic, and most people don't. They're not going to understand what or means in everyday usage. Okay. Anyhow, here you get x then equals negative 11 thirds. And then you check. I want to check if I can screw up. Okay. is the absolute value of 3 times -5/3 plus 8 equals 3? I'll put a question mark there. Is it so? Well, 3 times -5/3 is -5. And add that to 8. Is that equal to 3? Well, -5 plus 8 is 3. So we've got absolute value of 3. Is that equal to 3? Yeah. So this solution, -5/3 works. We put in -11/3 times the absolute value of, sorry, 4. Uh-oh. Equation. I started here, but original equation up here with the 12. Okay. And you end up with 4 times 3 equals 12. And you know that's right. Okay. On this one, you replace x by -11/3. You get 4 times the absolute value of 3 times -11/3 plus 8. Is that equal? Well, you get 4 times -4 times the absolute value of -11 plus 8. That equal to 12? Well, -11 plus 8 is -3. Is that equal to 12? The absolute value of -3 is 3, so that's 4 times 3 equals 12. And now we've checked both solutions. I emphasize checking your solutions. If we don't do enough of that, which means that a lot of people tend to make mistakes and not catch them, so you don't learn how to correct the mistakes. And now what did I do? The sheet that had the problems on it. I would laid it there, but I laid it over there. Okay. Okay, so that's absolute value. Now we've got a lot of problems on percents. They all come down to something like this. I'll do 2 examples. What is 5% more than 60? Five percent more than 60 is 60 plus 5% of 60, which is equal to 60 plus 0.05 times 60, which is equal to 60 plus 3, which is equal to 63. Now, this is something you simply should know from middle school, but most pre-calculus students don't know it. Okay? And as a matter of fact, in the pre-calculus support course, and you can view this. You go to the assignments page and click on MDE 61 and look at what we did in class last time. you'll find where we do a whole lot of discussion of this and really develop it, and I think that might be useful to you. And then we extend it. We extend it by saying, okay, well, it's 5% more than that. Well, you're gonna do 63 plus 105 times 63. And that develops immediately into the big topic that we're gonna spend most of the rest of the pre-calculus course on, which is exponential functions. So this is very important. That's all I'm saying. You have to understand percents. There really is a much better way to do that. Okay, another problem involving percents. $60 is 5% more than what? Okay. Now, there's a tendency to want to just take 5% of 60 and subtract it, and you get 57. But 5% more than 57 isn't 60. It just, if you check it, it won't work. And that's another reason we always check. Okay? It seems like that ought to be right. But the first time, it seemed to me like, okay, yeah, that ought to be easy. And then I did it and I checked, and I said, oh, no. Okay. And I don't think I made that mistake anymore. Okay, anyhow, 65% more than what? And open math explains this for someone. Okay, let X be the desired number. Then X plus 5% of X has to equal 60. Well, X plus 5% of X is the same as X multiplied by 1 plus 0.05. That's just the distributive law. X times 1 is X. X times 0.05 is 0.05X. So you can write this as X times 1.05 equals 60. So that X multiplied by 1.05 divided by 1.05 equals 60 divided by 1.05. So X equals, well, I'll just say etc. Because 60 divided by 1.05 is real close to 57, but it's a little more than 57. Okay. So that's how you would solve a problem that asks you that. And that's probably the trickiest problem given percents. Okay. Now we have a bunch of problems involving geometry. You had a section on geometry. So you might want to review it so you know what the basic formulas are. Okay. Has diameter 12. What are its circumference in its area? Well, circumference equals pi times diameter, which is the same as 2 pi times radius. You know what pi is? That's 3.14. Okay. If you don't know that, make sure you do when you go into the test. Okay. You gotta know at least the pi is 3.14. It used to be we had no 3.1416, 3.141592. Okay. To a lot of decimal places. But that's kind of unnecessary. You just have to know how many decimal places to use, and you can always look up if you don't remember all the decimal places. Anyhow, that's the circumference. Okay. Well, you're given the diameter, and then, why is it 2 pi times the radius? Well, because by definition, it's pi times the diameter. That's the definition of pi. And the diameter is 2 times the radius. So there's no mystery where that 2 came from. You just change diameter to 2 times radius, put the 2 out in front of the pi. So in this case, the circumference is pi times 12. So we just write that as 12 pi, and that'll be perfectly fine answer. You don't even have to know 3.14. If you look at the solutions that are given here, it says, well, it's going to be 12 pi, or it's going to be, what is it, 36, 12 times 114, 37.4 for something. Okay. I'm not sure about that. 4. Something along that line. Actually, that'll be closer to 37.7. Okay, well, that's all right. Circumference is this. Okay, area. Pi r squared. This is something that nobody should be allowed to walk the streets not knowing. If you're in polite society, you got to know what the area and circumference of a circle are. It's just part of what ought to be common knowledge. Okay. But anyhow, area pi r squared. It's a little confusing. So you have 2 pi times the radius, you have pi times the diameter, and then you have pi r squared, and it is easy to confuse things. The idea is, though, that like if you do the area of a rectangle, which is the easiest thing to understand, you multiply the length by the width, right? So you would get square units. If you have 8 feet by 4 feet, you get 32 square feet because you're multiplying feet by feet. Okay. If R is in feet, the area has to be in square. That's worth pondering and kind of assimilating. Again, it's just part of the way the universe works. In any case, that's pi times 12 squared, which is 144. Another part of what the universe is the radius of half of it. Excuse me. Radius is half the diameter. So you got pi r squared. Radius is half the diameter. So the area is pi times 6 squared, which is 36 pi. Okay. Now there are a lot of problems in here on geometry. course, you're only gonna get one. You really do. Want to pay attention. To the geometry stuff because it's pretty fundamental. Okay, so we have another type of problem. Area of a rectangle is, let's say, 96. Length is 12. Find the perimeter. Well, it doesn't hurt. Yes, a rectangle is a very good idea. You guide yourself with a sketch. You have 12 here. You have area 96. Well, 12 is the length. Area is length times width. Okay, we know the area. We know the length. So we have something here that we can easily solve to find the width. Now, why would we do that? Well, it's because we're asked to find the perimeter, and even if we don't immediately know what the perimeter is, we know that we can at least find the width of this thing. Just using the very most basic area relationship of all. Okay. The width is area over length, which is 96 over 12, which is 8. Okay, well, we just found the width. So now we know width is 8. And now we've got a picture. And if we want to complete the picture, we know this is a rectangle, so that this side is also 12 and this side is also 8. And if we get that far on the test and don't know what the perimeter is, I'd probably give you at least half credit. Because that's some pretty good reasoning there, okay? But you should know what the perimeter is. It's just how far you gotta walk to get around the thing. That's how far it is here, around here. Okay? So perimeter is most basically length. If you go around, you gotta go to the length, then you gotta go to the width, then you gotta go to the length, then you gotta go to the width. Just by common sense, it's length plus width plus length plus width. All right. And of course, if you like, that's 2 times the length plus 2 times the width. But I'm just going to use length plus width plus length plus width. That gets 12 plus 8 plus 12 plus 8, which is 60. Now, open math and pretty much any textbook is going to give you a formula for perimeter. Going to give you a formula for area. And then it's going to try to get you to understand what perimeter and area are after it gives you the formula. Not always, sometimes it explains what the perimeter is, and it tells you why the formula is what it is. And the formula would be like G equals 2L plus, W plus 2W. Well, that's great, but you don't really need it to answer this question. You just got to know what a perimeter is. Okay? You don't need a formula. But sometimes you do want to use that formula. For example, let's say a rectangle, sorry, perimeter. Now, wait a minute. How do I save these problems? On the test. Look at one. Make sure that I'm. There are problems where you're given that the length is 5 more than the width and the perimeter is such and such, find the area. But I haven't included any of those, and that's what I was inclined to do just a minute ago. But that's not. We do want to get this picture. Okay. Um, yeah, I don't do it with a rectangle. I do it with parallelogram. Um, I'm just going to say, because we can't spend too much time on the jet, we could easily spend more time when we can afford the geometry. We'll come back and do a little bit. If we have time after we get through a couple more things. Okay, now we have problems on exponents, and I'm actually going to work a couple of these because I had a lot of trouble getting these to work out. Remember, these are randomized, so that my randomized instructions with the language that I'm using that I developed otherwise, maybe, but it allows me to interpret a text file into 1,000 versions. Problems. Anyhow, I'm not totally sure of some of my results. So let's just look at a couple of these. Okay, let's look at like number 176. I'm not going to do all 4 of these, but we have x to the 8th divided by 1 to the 5th raised to the -3. And you're asked to express this using no denominators. Well, to start, just use the rules for exponents, which says that you have a power of a power, you multiply the powers. So this is x to the 8th, first of all, to the -3 over y to the 5th to the -3. Well, that's equal to x to the 8th times -3 divided by y to the 5 times -3. Which then is x to the -24 divided by y to the -15. Well, x to the -24 is 1 over x to the 24. I'm going to write this way. I'm going to write this first of all as x to the -24 multiplied by, sorry, divided by, y to the negative 15. X to the negative 24th and y to the negative 15th both have negative exponents. I asked you to simplify this and do it without negative exponents. Now, again, looking at partial credit, if you get it down to here and you get it right, I'd probably give you half credit, but I want to see how you express it without negative exponents. Okay. So x to the negative 24th is 1 over x to the 24th. And that's divided by 1 over y to the 15th. Because of the rule, a to the negative b becomes 1 over a to the b. So now we've got positive exponents, but in division sign doesn't put this thing into totally simplified form. You got down to here, give you a little more partial credit than you have here. Probably 6 or 7 points out of 10, but to complete this, then want to write this as 1 over x to the 24th times y to the 15th over 1, using the rule says when you divide by a fraction, you multiply by the reciprocal. And now this, when you multiply the numerators, comes out y to the 15th, multiply by, you multiply the denominators, you get x to the 24th. So there it is. And actually, I think this problem asks you to do it using no denominators. The first problem asks you to do it with positive exponents only. So this really is number 176. What I'm doing here is expressing this fraction with positive exponents. Okay, if I wanted to express it with no denominators, well, we go back to x to the negative 24 times y to the 15th divided by y to the 15th by y to the negative 15th. Okay, well, there's a denominator. That equals x to the negative 24th divided by y to the negative 15th, which equals x to the 24th times 1 over y to the 15th, which equals x to the 24th over y to the 15th. So you want to be able to do these kinds of manipulations because you will have a problem much like one of these three here as letting of exponents. That'd be problem 175, 176, 177. 175 asks you to simplify using positive exponents only. 176 has no denominators, and 177 says no denominators. So, and just because there are two of them with no denominators doesn't mean that I set up the probabilities here in such a way that you're more likely to get one that says no denominators than positive exponents only. Be prepared to do both, okay? Because I do believe this has been set up, and if it hasn't been set up that way, it will be, to where you're equally likely to get one like 175 or one of the two between 176 and 177. Just be prepared to do anything. Okay. Let's solve the system. And 6x plus 8y equals 36. Okay. Now we have a couple of choices here. We could multiply this first equation by -8 and the second equation by 7. That would give us a -56y and 56y. Just take the 8, multiply by the 7, take the 7, multiply by the 8, which got to multiply the whole equation, and make it up negative. Well, equally easily, we could multiply like the first equation by -6 and the second by 8, and that would give us a -48x and a 48x, and the x's would go away. But even easier than that, since these have a common divisor, I could just multiply this and by 3 and this and by 4. That's what I'm going to do. Now again, open math, going out of this by substitution. So we have I do know this -3 times the first equation and 4 times the second equation. So I do -3 times the quantity 8x plus 7y equals -3 times 37. And I do 4 times the quantity 6x plus 8y equals 4 times 36. That gives me -24x minus 21y equals -111. And 24x plus 32y equals 144. Okay, well, I add first equation to the second. -24x and 24x gives me 0. -21y and 32y gives me 11y. -111 and 144 gives me 33. Y is 33 over 11, which equals 3. I take that result and plug it into the first equation. And I get 8x plus 7 times 3 equals 37. So that's 8x plus 21 equals 37. Subtract 21 from both sides and so forth. You're going to get x equals 2. So y equals 3 and x equals 2. Then I'm not going to write it out, but you should. Check it. 8 times 2, because that's a 2 is 16. 7 times 3 is 21. 16 and 21 gives you 37. And then check it in the second equation to be sure. Okay. 6 times 2 is 12. 8 times 3 is 24. And 12 and 24 is 36. So there it is. Now, alternatively, graph the equation. You can graph both of these. And I'm not going to go into the detail of that. Just going to say, no. talks about graphing linear equations. Yeah, I'm not sure I included graphing linear equations in this sentence. That would be a terrible oversight, but if it's not there, you can expect to see it on the file. Oh, there it is. But you do need to be able to graph linear equations in order to do the solution by graph. Just this particular equation, set of equations, is a little bit of a pain to graph. Like one graph would be here. Oh, never mind. I'm not going to mention it. Well, I'm not mentioning it. Let's do it right. Look, line here, and out here is 6. Up here, X is 4 out. And then this equation is going to have a little greater slope. The y-intercept is going to be up here. 2 are going to intercept about here. Graph something like this. And this point of intersection would be. I haven't gone into detail how to graph that. I may just look at too steep. 2, 3 should be. Actually, 2, 3 should be to the left. If I can steep it up. Anyhow, that's what you do. Let's go to the idea of the equation of a straight line. That's really important. Do a straight line. Do the point 0, 7, and 8, -3. As we want to draw graph. So I'm going to put 0, 7 here. And I'd like to draw a line here so that 5 and 7 along this line. Okay. And then 8, -3. Well, that's 7, 8 might be about here. So here's line where x equals 8. And if y is 7 here, y would be -3 about here. So you can have a point down here. These 2 points are on the graph. Here's 0, 7. Here's 8, -3. I've advocated that you draw what I call fundamental triangle. Although if you want to use a formula, well, that's okay. You can learn more. Do it this way. The run from here is 8. For obvious reasons, you're going from the y-axis where x equals 0 out to where x equals 8. So x equals 0 to x equals 8. The rise goes from y equals 7 down to y equals -3. That's -10. I also advocate that you put arrows that start at this point and end at this point. So you have a direction, so you know whether the rise is positive or negative. If you go from left to right, the run will always be positive. Your rise will be negative. If this point's lower than this one, positive or higher. So now the slope is rise divided by run, which is -10/8. Form y equals mx plus b, m is the slope. B is the y-intercept. In this case, you're given the y-intercept. It's 0.7. The y-intercept is 7. Slope is m. So that's -10/8 times x. And b is the y-intercept, which is 7. Of course, -10/8 reduces. I could reduce that to 4. Just decided to save that to the end. So it's not to confuse things. So that's very straightforward. Now there are formulas you can use, computer formulas. I think you do better with a picture, but it's up to you. If you do it by the formulas, I'll accept it for this course. But you get better preparation for pre-calculus that you engage yourself in. Okay. Now there's another where we have to do a straight line. Let's say we do a straight line through 2/6 and 8/16. Now, we could directly use y equals mx plus b in this case because we were given the y-intercept. 0.07 tells you what b is. In this case, you're going to be able to find the slope. You plot 2 points, you draw that triangle, you can find the slope. If you want to use the formula, okay, just make sure that you can remember the formula right, because I'm not sympathetic if you use the formula to get it wrong, okay? Okay, so we have the 0.26 here, and then the 0.816 up here. If I want to get my slope, I sketch a triangle, horizontal here, vertical here. What's the run? Well, we're going from x equals 2 to x equals 8. It's 8 minus 2 equals 6. What's the rise? We're going from y equals 6 to y equals 16. It's 10. So the slope is rise divided by run equals 10/6. I've got room for rise to reduce. So it's 5. So there we have the slope. Now, that's fine. Y equals mx plus b. M equals 5/3. So now y equals 5/3 x plus b. We still have to find b. Find b, we substitute the coordinates of either point. Well, Using the point with smaller numbers, which might be slightly more convenient. Using 2, 6, we get y equals 5. Well, no, y. Well, okay, y equals 5/3 x plus b. 5/3 x plus b becomes 6 equals 5/3 of 2 plus b. And let me see what else we need to do here. So we want to look at. Maybe not. Oh, yeah, I understand. Okay, we do have to do a little of that. We get b equals, that's gonna be 10/3. We subtract 10/3 from 6. We get 8/3. Is that right? That can't be right. We get 10/3. We have 18/3. 10/3. It's 8/3. Oh, yeah, that's okay. So finally, our answer is y equals 5/3 x plus 8/3. Now the details of the numbers, well, that's important, but that's not what you need to focus on. What you need to focus on is you find the slope, you get this. You still have to find b, so you take the coordinates of one of your points, you replace y and x with the coordinates, and you solve for b, and then you plug that in and you've got your equation. And presumably you've done that on your homework. Okay. Quickly. Expanding a square or a cube, which we've done in class recently. Let's take one of the examples. Let's look the way it's done. You know, there's you're gonna have to post a revision. On numbers 246 through 249, my expressions aren't what I intended. You could do the problem, but I'm going to change these expressions slightly. So I'll show you what the expression should look like. Actually, I'll do that. Let's just do this. X plus delta x squared minus x squared. That means x plus delta x multiplied by x plus delta x minus x squared. And if we multiply that out by the distributive law, we have x plus delta x plus delta x times x plus delta x minus x squared, which is then x squared plus x delta x plus x delta x plus delta x squared minus x squared, which is x squared plus 2x delta x plus the delta x squared minus x squared. My point is, if you see this and you want to write out x squared plus your delta x squared, and that's not right. You use the distributive form. Then, of course, you have an x squared and a minus x squared. So kind of indicate, well, we got an x squared here and minus x squared here. And that just leaves you 2x delta x plus the square of delta x. Bottom line on the problems that involve expanding things is use the distributive form. Okay? Okay, well, it doesn't cover absolutely everything, but it certainly covers most of it. So please use this video if it's useful to you, especially if things you don't understand. And if you have a problem, a question between now and next Wednesday, and you don't understand something, email me. Now, if I'm stuck in traffic, I don't do thumb typing on phones, so I won't be able to respond at that point. But hopefully, between Sunday and Tuesday, I would have an opportunity to respond. And of course, we can talk more Wednesday. The test will be in the testing center this afternoon. It'll be due at the end of next week. Okay? Fair enough? So, if you have questions, we can deal with more of them on Wednesday.